All right, so we want to look at the solutions to quiz 2. Part 1 was geared towards identifying the correct IUPAC name given the structure. So if we look at A, so A has the following structure. We want to find the longest chain. And so again, I would lasso or fill this in. So the longest continuous chain is going to be found in what I have rendered in red. Now, of course, we want to number this chain. We could number this 1, 2, 3, 4, 5, 6, 7. Or we could number this 1, 2, 3, 4, 5, 6, 7. The sums are going to be exactly the same. So when the sums are exactly the same, you want the substituent that would appear first in the alphabet to have the lowest number. So we're going to go in the order of what's rendered in blue, which means we are going to have 3 chloro, 4 iodo, 5 methyl heptane. And of course, there's no space between the L in methyl and the H in heptane. 3 chloro, 4 iodo, 5 methyl heptane. Common mistakes on this problem included choosing the longest chain to be 6. So a lot of people just did this. So this is a real common mistake in the beginning. Of course, that's wrong. Also, numbering that is rendered in white. So the best answer is 3 chloro, 4 iodo, 5 methyl heptane. Let's look at part B now. This kind of has a little bit of everything. We've done examples in class like this. So we want to find the longest chain. That's going to be pretty easy to find on this one. And we want the OH to have the lowest number. So we should number 1, 2, 3, 4, 5, 6, 7, 8. Because if we numbered from left to right, it would be 1, 2, 3, 4, 5. OH prefers to be 4 in terms of the nomenclature preferences. So we have 1 bromo, octan, five, 7, diene, 2-ine, 4-ol. 1 bromo, octan, 5,7-diene, 2-ine, 4-ol. And to be even more specific, we should probably the O in octan And the O in bromo should not have a space between it. So that's part B. Moving on to C. We know which way we have to number here because the carboxylic acid carbon has to be the lowest number, because that's called the locant, by the way, because it is the most oxidized carbon. So carbon 1 is our locant. It is the carbon that's involved in the key functional group in the molecule. 4-oxo hexenoic acid. You don't have to put 1-oic acid because a carboxylic acid is assumed to be at carbon number 1. And unless you have a di or tricarboxylic acid, you'll never have to worry about showing where the locant is. It's always assumed to be 1. 4-oxo 2-hexenoic acid. So now let's look at part D. And we have an aromatic ring. Longest chain has 1, 2, 3 carbons. So this is going to be a 2-propanone with a phenyl group substituting one of the hydrogens. So we'll go 1 phenyl, 2-propanone. Now if you have phenyl 2-propanone, that works as well. And so this is the last of naming the compounds. So now we need to go to part 2 of the quiz, which is given a name, draw the structure. So A is 2-amino butanoic acid. Butanoic acid has 4 carbons. So notice how I start at the end and then we'll work my way back. Carbon 1, carbon 2, 2-amino butanoic acid. So the proper answer for this one is going to be a structure. And honestly, since we've done FTIR and mass spec, you should be asking yourself, what should the mass spec look like for this compound? What should the FTIR look like for this compound? Of course, with B, I kind of socked it to you a little bit. You have 3-iodo, 2-methyl octan, 2,4-diene, 7-ine, 1-O. So I need 8 carbons where there's a triple bond between 7 and 8. Carbon 8, carbon 7. I'm going to erase a little bit of that. That's just a cosmetic thing. Carbon 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8. Double bonds between carbons 2 and 3 and carbons 4 and 5. Alcohol at carbon 1. Methyl group off of carbon 2. Iodine off of carbon 3. Of course, you could have flipped this around as well. But here's the correct answer for part B of question 2. All right, so 2 more. C, probably the easiest one on the quiz, cyclopropyl, cyclohexane. Simply draw cyclohexane, a 6-membered ring, and on any carbon that you choose, have the cyclopropyl group. Which leads us to the last question on the quiz, D. 6-methyl bicyclo 3, 2, 1. Well, that's a problem. Now you should be able to figure out that it is octane. So you got two bridging carbons. You're going to have 3 carbons that separate to the left. You're going to have 2 carbons that separate to the right. You're going to have 1 carbon that bridges in the middle. 1, 2, 3, 4, 5, 6. Here's your methyl group. Now, how many carbons are in this ring system? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So it's an octane. We could number from the bottom and go counterclockwise. That would be 1, 2, 3, 4, 5, 6. So whether you go clockwise or counterclockwise, you get the same chemical structure. All right, so that does it for this quiz. Expect a couple of other quizzes on this next week as I help prepare you for your first exam on Wednesday.